This object is simply a piece of another solar system that was expelled, and it has been traveling through interstellar space.
It has 8 times more carbon dioxide than water. When NASA's James Webb Space Telescope turned its $10 billion infrared eye toward the interstellar visitor 3 ice atlas on August 6, 2025, it revealed something that, according to our understanding of cosmic chemistry, simply should not exist. This discovery has sent shockwaves through the astronomical community. Combined with Hubble's unprecedented images showing a hidden nucleus that can't be directly observed, we're looking at an object that breaks every rule we thought we knew about visitors from deep space. The telescopes have revealed chemical signatures and physical properties that open a universe of terrifying and exciting new possibilities about what's actually traveling through our solar system. A revelation from space's most powerful eyes. In the infinite darkness between stars, where objects from alien worlds carry the chemical fingerprints of their birth, something extraordinary has emerged from 4 billion years of interstellar travel. On July 21st, 2025, when NASA's Hubble Space Telescope captured the most detailed image ever taken of 3 ice atlas, it revealed a visitor unlike anything in our cosmic neighborhood. But it was James Webb's infrared vision that would expose the true impossibility of what we were witnessing. At first, both telescopes seemed to be observing a remarkable but explainable interstellar comet. Hubble showed a teardrop-shaped cocoon of dust streaming from what appeared to be a typical icy nucleus. Webb detected the expected signatures of a comet's coma, the cloud of gas and dust that forms as solar radiation heats the object's surface. But as the data was analyzed, the routine became revolutionary. You see, when comets approach stars, they follow predictable chemical behavior patterns established by billions of years of observation. Water dominates their composition. Carbon dioxide appears in small amounts, and the ratios between different gases follow the fundamental laws of cosmic chemistry. 3 ice atlas shattered every one of these rules. The real shock came when James Webb's near-infrared spectrograph completed its analysis of the chemical composition. The telescope had detected one of the highest carbon dioxide to water ratios ever recorded in any comet, 8 parts carbon dioxide to 1 part water. Normal comets contain around 4% carbon dioxide. This thing was fundamentally different from anything that should exist in the universe. This is where the story takes a sharp turn from remarkable discovery into cosmic impossibility. Dr. Martin Cordner, who led the James Webb analysis team, made the admission that would rewrite textbooks. 3 ice atlas wasn't just unusual, it was exhibiting chemical signatures that challenged our understanding of how planetary systems form and evolve. The thing nobody tells you is that creating a comet with this chemical composition requires conditions so extreme and specific that they stretch the boundaries of what natural processes can achieve. What Webb and Hubble had found wasn't just rare. It was something that, by all known laws of cosmic chemistry, shouldn't exist. This wasn't just another space rock. This was a cosmic impossibility, traveling at 130,000 miles per hour through our solar system. What the telescopes actually revealed. Many people are crazy about space discoveries, but the scientific community is obsessed with verifiable impossibilities. As James Webb and Hubble continued their coordinated observations through August 2025, they revealed an object that defied every category astronomers use to classify cosmic visitors. Hubble's high-resolution images showed something that left Dr. David Jewett from UCLA speechless. Despite being the most powerful optical telescope ever built, Hubble could not directly observe the nucleus of 3 ice atlas. The solid heart of the comet was completely hidden within a mysterious dust cocoon that seemed designed to prevent observation. In Hubble's 3 decades of operation, it had never encountered a comet that could so effectively hide its core. When the team estimated the nucleus size based on brightness and thermal models, they found themselves facing another impossibility. The diameter was somewhere between 1,000 feet and 3.5 miles, but the uncertainty wasn't due to measurement error. It was because the object was behaving unlike any natural body they had ever studied. The thing is, James Webb's infrared capabilities revealed why Hubble couldn't see the nucleus. The object was surrounded by a massive cloud of carbon dioxide gas extending at least 348,000 kilometers into space, roughly the distance from Earth to the Moon. This wasn't the modest coma typical of comets. This was an atmospheric envelope of impossible proportions. Dr. Marco Micheli from ESA's Near-Earth Object Coordination Center, who helped coordinate the observations, made an observation that sent chills through the research team. The chemical signatures detected by Webb didn't match any known formation process for comets in our solar system or any theoretical model for objects from other star systems. When you analyze what the two most powerful space telescopes actually detected, the conclusion becomes inescapable. 3I Atlas exists in a state that our current understanding of physics says is impossible. The chemical ratios, the hidden nucleus, the massive gas envelope. None of it should be able to maintain itself during millions of years of interstellar travel. Yet here it was, racing through our solar system and challenging everything we thought we knew about what's possible in the universe. But there's another piece of this cosmic puzzle that makes the Webb and Hubble findings even more extraordinary. When the telescopes analyzed not just what gases were present, but how they were being released, they discovered behavior that no natural process should be able to produce. James Webb detected that the carbon dioxide emissions weren't random outgassing from solar heating. The infrared spectroscopy revealed emission patterns at 4.3 micrometers that showed systematic, organized release of CO2 in quantities that would require the object to be almost entirely composed of carbon dioxide ice. But here's the impossibility. Such an object couldn't survive the journey through interstellar space. You see, carbon dioxide ice sublimates at much lower temperatures than water ice. An object made primarily of CO2 should have lost most of its mass during the millions of years it spent traveling between star systems. Yet 3I Atlas was producing CO2 at rates that suggested it contained vast reserves of this volatile compound. Sphere's observatory data from August 7th to 15th confirmed Webb's impossible findings. The telescope detected a point source signature with no significant extended structure, meaning the massive gas production was coming from an incredibly compact nucleus. This violates every known model of how comets release materials. Dr. Stephanie Milam from NASA's Goddard Space Flight Center, who analyzed the combined Webb and SphereX data, made a statement that would echo through the scientific community. The emission patterns suggested that 3I Atlas wasn't just releasing gases, it was maintaining them in organized structures that defied the chaos of interstellar space. The thing nobody tells you is that maintaining such organized chemical emissions requires either exotic physics we don't understand or active processes that go beyond natural outgassing. When Hubble's visual observations were combined with Webb's chemical analysis, the picture that emerged was of an object that seemed to be actively managing its own composition. Furthermore, the telescopes detected something that made the impossibility even more profound. While producing massive amounts of carbon dioxide, 3I Atlas showed only trace amounts of water vapor, the opposite of every comet ever studied. It was as if the fundamental laws of cosmic chemistry had been reversed. When objects from deep space are examined by our most powerful telescopes, you expect to see the scars of billions of years of cosmic weathering. But not all things are what they seem. As Hubble and Webb continued their observations, they revealed an object that seemed to have defied the natural aging processes that affect all interstellar travelers. Hubble's detailed imagery showed that 3I Atlas had a smooth, almost geometric dust envelope rather than the chaotic, irregular coma typical of natural comets. The teardrop shape was too perfect, too symmetrical for an object that should have been battered by cosmic radiation and micrometeorite impacts during its interstellar journey. But the most impossible discovery came when astronomers tried to determine the object's rotation period. Multiple telescopes observed brightness variations that should indicate how fast the nucleus was spinning. What they found defied physics. The rotation appeared to be slowing down in a controlled manner, as if something was actively stabilizing the object's spin. Dr. Tony Santana Rose, who led the rotation analysis, found that brightness variations decreased from 0.3 to 0.2 magnitudes throughout July 2025. This wasn't random. It was systematic stabilization that required either impossible coincidence or active control mechanisms. The Webb telescope's infrared analysis revealed another layer of impossibility. The telescope detected organized thermal emissions that suggested internal structure rather than the solid ice and rock composition expected from natural comets. The temperature distribution patterns showed zones of different thermal properties, as if the object was constructed from multiple materials rather than formed from natural accretion. When Italian astronomers led by Virginio Oldani analyzed Hubble's high-resolution images, they found something that challenged every assumption about natural objects. The orientation of the suspected rotational axis pointed towards specific stellar coordinates with mathematical precision, not the random alignment expected from billions of years of gravitational perturbations. The conclusion was inescapable. 3I Atlas wasn't just hiding its nucleus from Hubble's cameras. It was maintaining structural and thermal characteristics that shouldn't be possible for any object that formed through natural processes and survived the journey through interstellar space. Science demands that we explore every natural possibility before accepting impossible conclusions. The Webb and Hubble findings, as extraordinary as they appear, could have explanations that push the boundaries of known physics without breaking them entirely. The unprecedented carbon dioxide ratios could result from formation in an exotic stellar environment we've never encountered. Perhaps 3I Atlas originated around a star with unusual chemical composition, or formed in the aftermath of stellar events that created conditions unlike anything in our galactic neighborhood. The hidden nucleus detected by Hubble might be explained by unique optical properties of interstellar dust exposed to cosmic radiation for millions of years. The organized thermal emissions found by Webb could be the result of internal chemical processes we don't yet understand. The answer is a tentative maybe. It would require natural processes operating under conditions so extreme and specific that they would be indistinguishable from the impossible. But the critical point is that two of the most sophisticated instruments ever built, telescopes designed to observe the impossible, have both consistently detected properties that exceed the boundaries of known natural phenomena. Perhaps the most unsettling possibility is that the discoveries made by Webb and Hubble are revealing gaps in our understanding so fundamental that we need to reconsider what's actually possible in the universe. The truth is out there, hidden behind a mysterious dust cocoon and producing impossible chemicals as it races toward the edge of our solar system at 130,000 miles per hour. And our best instruments are telling us it defies everything we thought was possible. Let us know what you think in the comments.